Hey guys, we're going to get started. Just a reminder, this is meeting room C, so we're here for alley cropping for climate resiliency, farm diversification, and cropping system services. So if this is not where you meant to be, B and A are that way. My name's Harper Zeitz. I work here at KSU's organic agriculture team. I'm just going to do a brief introduction for our two speakers, which is Dr. David Butler and Jody Thompson, and they're going to be speaking on alley cropping. Just a reminder, if you have any questions, wait for Jody or someone to bring you the mic so that we can get that in the recording for people who are not here and want to watch the recording. That's the only way to pick up our questions. And then also make sure you fill out the survey form that I gave everybody. That's just for Oaks purposes. Leave them at your seat, and I'll collect them at the end of this. Thank you all.
All right, good afternoon, everyone. So I'm David Butler. I'm at the University of Tennessee. I'm a professor there in the Department of Plant Sciences, mostly do research in organic cropping systems, mostly with fruit and vegetable crops, but a few other things. And then mostly focus on soil, plant, microbe interactions type research. What I'm going to talk about today is alley cropping in organic vegetable systems. So I'm not sure what your interests all might be. I'm sure they're very diverse. So if you all have questions while I'm going, feel free to put your hand up. Jody will bring you the mic, and you can ask questions while we're going. I'm going to talk here for the first half, and then I'll turn it over to Jody for a little bit towards the end. And again, any questions you have, feel free to hop in. So I mentioned I'm going to talk about alley cropping. Probably you all have heard this term, but alley cropping is a type of agroforestry, and I've got a photo right here. And I've got a number of photos through this presentation, a number of other slides that are mainly meant to get you all thinking about alley cropping, get you all thinking about the possibilities of alley cropping, get you all thinking about maybe what the challenges of alley cropping might be if you were to implement a system like this. So first here we see one alley cropping system. We've got herbaceous crops. I think this is soybean grown between a woody crop, and this is walnut in this case. This is just an image I took offline. But what is alley cropping? It is a type of agroforestry with cultivation of crops grown between rows of woody plants. So it could be a lot of different things. Usually we think about herbaceous plants, not woody plants grown in the alleys, but that's not entirely true. For example, raspberry could be grown between trees, and that could be another type of alley cropping system. But usually we're talking about herbaceous plants grown between either, say, woody shrubs or trees. Also sometimes called silvo-arable systems there from the tree and the arable crop, we get that term. I like to show this image early, again, gets people thinking about what alley cropping is and also what maybe some of the challenges and opportunities might be, right? So this is, I think it's from France, yeah. This is walnut again, and we've got small grains grown between the walnut here, and so we've got that alley, we've got that herbaceous crop, the small grains. A couple things people often notice here is that it makes you think about the mechanization of a system like this, right? And how that equipment here is adapted to that system, probably, one or the other here. They either got equipment at that size or they designed that system to fit that equipment. But that's something you'll have to think about as you design an alley cropping system. How does it fit the types of equipment that you might use in that type of system? You also maybe notice here that these trees are quite large, right? And so there's some above ground competition for resources and some below ground competition for resources between these two plant species that you've got going. And then another thing people often notice is there's a third type of vegetation here, right? That's here under the tree. That's something that needs to be managed, a different type of vegetation that's not within that alley. Maybe it's weedy vegetation, maybe it's some kind of perennial grass or something like that. All right, so why do we want to talk about alley cropping systems? There's a lot of potential benefits. One would be maybe there's improved microclimate benefits for the crop growth. We'll talk about what some of those might be. Maybe it's reduced air temperature, for example, reduced wind speed for improving crop growth. Potentially increased diversity of farm enterprise. The two examples I've shown you already, that woody crop is something that's harvestable as well as the herbaceous crop. Potentially enhanced nutrient cycling and availability. We'll talk some more about that. Potentially improved soil quality and reduced erosion through various mechanisms. Potentially increased functional biodiversity, meaning, we expect there might be more biodiversity in a system like this. You've got, say, a woody tree versus that herbaceous crop, those are going to host a lot of different organisms than either alone might be able to host, but also they might provide a function to that cropping system. It's not just, it's great we have more of those different types of species, which is generally true, but also that they might provide a function, like maybe they'll help to improve pest control in that system by increasing that biodiversity. So that's a potential benefit. Improved watershed protection and improved hydrologic function, again through the action of that much larger biomass, much larger rooting system that you get with that woody crop versus just having that herbaceous crop. And also the diversity you get from having that herbaceous crop and that large woody crop. And then overall environmental benefits and enhancement of ecosystem services, a lot of those, of course, related to those topics that are mentioned above here. So if we think about how do trees, woody plants, how do they impact that environment around them in an alley cropping system? So I've got this older drawing that comes from kind of a classic agroforestry textbook, and some of you may have seen this, and it's very simplified, but it helps to illustrate some points, right? That you have this woody tree, this woody species here. How does it affect the microclimate around it, right? And I'm sorry some of those are small, but I can read them for you. So you've got this canopy here, this very large canopy of this tree that is going to interact with wind, it's going to interact with rainfall, and it's going to interact with solar radiation and change how then that herbaceous crop in the alley is exposed to those types of microclimate conditions. So just as an example here, it says for associated microclimate conditions above ground, you have reduced radiant energy, reduced air movement, reduced evapotranspiration. So evapotranspiration is evaporation, like from the soil surface, and transpiration, which is water leaving the plant put together. And then reduced maximum air temperature and increased minimum air temperature. So some moderation of the air temperature in that environment. And then associated soil conditions, potentially increased organic matter, and along with that, increased cation exchange capacity and nutrient concentrations, potentially increased soil moisture and moisture retention, reduced surface temperature, and increased soil stabilization. And you can kind of imagine how many of those processes might occur because of the presence of that tree, that very large biomass that stays there as a perennial and its large root system versus just having, say, an annual herbaceous crop especially, but even other herbaceous crops potentially. As we think about that microclimate modification, it can be a benefit to vegetable crops. And especially as we think about vegetable crops in a region like ours here in the southeastern US that has some environmental conditions that can be very stressful to vegetable crops, especially things like heat extremes at certain times of the year, and especially those that might be exacerbated by extreme weather events along with climate change. So just as an example, not from alley cropping systems, but from research on windbreaks, which historically, there was a lot more research on windbreaks, not a lot of recent research, but research suggests that vegetable crop yield can be increased through the effects of windbreaks. A number of studies have shown this. More of the research has been done with field crops than vegetable crops, but vegetable crops tend to be fairly susceptible to the effects of wind through various mechanisms. But what this just shows is that the effect of a windbreak on yield of a given crop just tends to follow a pattern like this, where you maybe have reduced yield compared to what you would have without the trees or the field average right next to the tree. This is distance from the windbreak or distance from the tree row. And then increased yield at some distance, usually 2 to 7 or 8 times the height of the tree. And then eventually, where the effect of that windbreak is no longer having an effect, you have that same average yield. So this highlights a few things here, right? That alley cropping environment is not going to be homogeneous. There's going to be different microclimate conditions depending on where you are in that alley, how close you might be to the tree. And then, of course, the width of that alley is going to be really important for a number of ways in which that microclimate environment might change depending on what happens in that external environment. Well, then we think, well, that's good that alley might help to give us some effects like a windbreak would to help to reduce wind through that site, maybe reduce transpiration from those leaves, reduce drying of that environment because you've reduced the wind, reduced other negative effects of wind. But those trees are also maybe providing some shade, and we're thinking about, well, is that too much shade for that crop? Is it going to have a negative effect, that removal of that light, that competition that comes from removing light? And it just depends, right? It just depends on what the crop is and what the particular conditions are in that particular alley. So some studies have shown that shading can reduce heat stress and help to provide increased yields through the action of shading in crops, even like bell pepper that we think, these are crops that are very well adapted to high heat conditions and really wouldn't have any benefit from shading. But some studies have shown that the shading actually can improve yield for these crops. So this was from a study in Georgia, and what they showed that with moderate shading, they could actually increase marketable yield. Not just not reduce marketable yield, but actually increase marketable yield. And so what they did was they had different shade levels, and this was with shade cloth, not with an alley cropping system, but very similar concept. And what they did is they had crops at no shade. They had that bell pepper crop at something like 30% shade, something like 50% shade, and then all the way up to 80% shade. So this is light in this first graph, or photosynthetically active radiation, just a measure of light. And so as you might expect, right, as you increase shading, you reduce the amount of light. But what reducing that amount of light did was it also reduced air temperature by a few degrees. It reduced leaf temperature by a degree or so, and it reduced root zone temperature by a few degrees. So all potentially beneficial to a crop that might be experiencing some type of heat stress. And so what they found with yield was that they actually had the highest total yield and marketable yield at 35% shading. So this is total yield at the top. So you see here with no shade, they're at 20 tons per hectare, and then they're up over 25 at that 35% shade. Very similar at 45 or 50% shading to what they had with no shading, and then reduced yield as you get to those higher shade levels. So what's happening in a graph like this? Right? You have two different effects. You have heat stress over here at no shade, and then you have light stress over here at too much shade, right? And so both of those are reducing yield. So they're optimizing production there at some moderate level of shade because they're able to reduce the heat stress effects on that crop. And there's a few things that happen with bell peppers when they're heat stressed, just in this crop as an example. But they're still allowing it to have enough light because of the light conditions in that particular system. Again, in this case, it's shade cloth, but the same thing would apply with an alley cropping system, that you have enough light for that crop, but remove the excess light that is causing the heat stress, because of course outside with the light, we also get the heat coming from the sun that might be a negative effect in this case. All right, so I've mostly talked about benefits to alley cropping. What might be some constraints? And I think you all might imagine already what some of these might be. The benefits are more long-term than short-term, right? Those trees that I've shown you in our examples, they take a long time to get to that size. So the benefits not only are more long-term than short-term, they change over the lifetime of that system, right? The environment changes over the lifetime of that system. And so it becomes much harder to manage and maybe more complex to manage. Not as huge of an issue in the United States, but in other countries this can often be an issue. Land tenure and availability, right? For rented land, it doesn't make nearly as much sense. Sorry, I keep doing that. It doesn't make nearly as much sense as maybe you own the land and make that long-term investment, because again, those benefits are going to accrue more in the long term than in the short term. Management of tree crop interactions, though, may be complex. I've just shown you two examples with light and with wind, right? That those relationships are going to change at different parts of the alley, different locations within that alley. They're going to change over the year as you think about how the season changes. You know, you're going from winter to spring to summer to fall, and it's going to change from year to year as that tree crop matures and its size changes over time, right? So that's very complex. And you have to think about how can you manage that complexity to reduce what might be competitive interference between those two species, or maybe allelopathic interference between those two species, right? The microclimate modification might not always be a benefit. I mean, you saw that maybe you could remove too much light in certain cases and reduce yield, but you could also maybe create a more humid environment that favors a certain foliar pest as a potential negative benefit if you're not able to manage that system for those particular crops. And the mechanization is less simple. We saw that photo with the mechanization earlier, that you can manage that system, or design that system rather, to be mechanized, but it might not always be easy to mechanize a system like this, depending on how it's designed. So some ways to think about managing that competition. I like to divide it into above and below ground. It helps me to think about it anyway. So if we think about what's above ground competition between plants, it's basically for one resource, and that resource is light, right? So plants and how they relate to light in an alley cropping system, it depends on a number of factors. One would be alley width and row orientation. A wider alley, there's going to be less interference to that crop in the alley as a more narrow alley, right? Just because those trees are going to provide more shading on a narrow alley, typically all other factors consistent than a wider alley. Row orientation plays a little bit of a role in this. Think about east-west versus north-south. The way the sun interacts with those rows is a little bit different in those two systems. Leaf canopy characteristics, if you think about different types of trees, right? They have very different canopy structure, they have very different leaf types, and all of these things change how that light filters through that canopy where they are shading those crops underneath. Leaf phenology, when those leaves are there, at the extreme, an evergreen is different than a deciduous tree, clearly, but also different deciduous trees, they leaf out at different times, they drop leaves at different times. So there's different phenology depending on the tree species that you might use. And then certain trees can be pruned in certain ways to change that competition above ground. And then we have below ground competition, right? Alley width. First, below ground competition is not for light, but now below ground competition is for water and for nutrients. And below ground, we can think about where those roots are distributed, just like we think about where that canopy of each plant is distributed. And so that's going to depend on things like alley width, the root distribution of that particular species, and then maybe the management of that system. So for example, just like you can prune above ground, you can also do things to prune below ground. You can use types of tillage, right, that are going to remove roots from certain parts of the soil. And so there's ways that below ground competition can be managed in that way. And then also, it's not mentioned there, but where those resources are distributed, things like where your irrigation is distributed, where fertility inputs are distributed, also changes the dynamics of that below ground competition between species. All right, so at the extreme, I like images that kind of get you thinking. I have this image for you. So this is from a study that was from sub-Saharan Africa, and I like it because it really illustrates this below and above ground competition concept. So in this study, what they had was, so this is corn, and this is a legume tree species, Gliricidia. It's a tropical legume species, used a lot in agroforestry systems. But in this case, you can see how the above ground competition is managed and how the below ground competition is managed, right? So during the cropping season here, which would be the wet season, when they plant that crop, they are cutting these trees to the ground level, incorporating all of that biomass because it contains a lot of nitrogen as a legume. And so they're adding fertility to the soil, but they've also released those corn plants from competition above ground, right? Because they've removed the ability of that tree to shade that crop during that growth cycle. So you see that removal from above ground competition, and then you can also see what they've done below ground, right? I see a lot of heads nodding, right? So they're using this hill system that basically put those roots below ground in a different location in the soil away from where the tree roots might be to help to manage that below ground competition that might occur. And so then that crop grows, it's harvested, And of course, those trees continue to grow then into the dry season because they're more able to take up resources towards the dry season. And then the next time the wet season comes around, they'll cut this biomass and they can rotate to another crop or do the same crop in that type of system, right? So it's a very extreme example, but you can see, I'm going to step back. It's a very extreme example, but you can see how they're managing above and below ground competition in that system. So the system that I'm going to talk about, and I have this image later, this was a schematic that I just drew up to illustrate the concept. You can think about in a vegetable system, you could do a similar thing, especially if you're using tillaged and raised beds. You can remove those below ground the roots below ground into a different zone of the soil and allow them to have less competition with that tree species in a particular system, just like they did in that previous system with the maize in Africa. All right, so thinking about how you decide how to design a system, right? And I think the way I approach this is that a lot of times you might have a vegetable grower and they might be interested, can I include trees in this production system, maybe in an alley cropping design? How would I choose the trees to use? But probably that's not the only way that people come to alley cropping systems. You might also be thinking, how could I design an alley cropping system and what might be the vegetable crops I could grow? But if you are in that first bucket where you have a vegetable system and you're thinking, well, how could I integrate trees into this system? Some things you might think about in terms of what types of woody plants might work in that type of alley cropping system. First is, what is the desired function that you have in that system? What about that vegetable system makes you think that you might want to have an alley cropping system, and what benefits do you think you could get or you might want from that alley cropping system? Maybe you're growing vegetable crops that you do see effects of heat stress, and you want to have some kind of microclimate modification in order to address that heat stress. It might be that you want to provide additional nitrogen to that crop through a legume or another nitrogen-fixing tree species. You might want to diversify that production system and have a different harvestable product, and we'll talk a little bit more about that, just like the nut trees that you saw in the previous example. And maybe you have problems with certain pests that you think you can have, that you can address somewhat with some biodiversity that might come from an alley cropping system. Or you just might want benefits of resource conservation or aesthetic improvement of the land that you're managing, and that the alley cropping system might be able to do that for you. So depending on that, you might choose different species, right? And then with that in mind, what you want from that system, you have to think about what are the characteristics of that system and what types of woody species might work in that particular system. What types of woody species might be adapted to that climate or that site or that particular soil? How easy is it to establish that type of tree? For example, can you find propagation material for it? Does it grow rapidly? Are you going to be able to maybe increase or shorten that length of time that you might see benefits from that particular tree species that you're growing? How does it compete with those crops in the alley, right? Different trees are going to have different above ground growth habits, how tall they get, how they branch, the types of leaves that they have, the overall leaf area that they have within that canopy that affects shading. They root in different ways, right? Some trees are much more shallow rooted, some are more deep rooted, some have a tap root. It just depends on the tree species. And then lastly, management considerations. Some trees, if you're thinking about a system where you want to cut that tree to the ground every year, like in that corn system, some trees are more able to respond to that type of pruning than other trees are, and maybe some might have a harvestable product in that case and others might not. So I grouped our common systems here into a few categories. The first three here are the main categories, and most of the examples I've shown you already were with nuts. So these are very common systems with nuts. You'll see a lot of examples in Europe of using nut trees in alley cropping systems, usually with grains, but also some with vegetables. So pecan, walnut, chestnut, and then hazelnut. Hazelnut's more of a large shrub, small tree. but similar concept. Biomass species used a lot in grazing systems rather than in crop production systems, but also used here in the US, it's usually pine or poplar. If you get into South America, it's usually eucalyptus. But same thing, just a biomass species for some type of biomass or timber harvest. And then nitrogen fixing species. I'm going to talk about black locust. You saw Gliricidia earlier. Alder is a nitrogen fixing species, but it's not a legume nitrogen fixing species, just as an example. And then lastly, fruit crops is something that a lot of people talk about, fruit crops as a potential with alley cropping systems, and they are. It's just a much more complex type of system than some of these others that I'm talking about. And then a lot of woody type species are used in woody ornamental or craft type species like willows and dogwoods and things like that. You'll sometimes see systems for the woody species in an alley cropping system. All right, so I have a few photos just to illustrate again and get you thinking. So this is a vegetable system. This is potato, and this is hazelnut. Hazelnuts get a little larger than that, but not a lot. So you can see this type of system. The above ground competition is very different here than what you saw with that walnut small grain system earlier, right? Because this is a much smaller tree species. You have a lot of light here in this alley that you might not have quite as much light if you had a larger species. Also, you can see it's a fairly narrow row spacing, again, because it's not a really large species. You still get a lot of light even at a narrow row spacing in this system. I forget what this tree species is, and I can't quite make it out here, but they're growing lavender here in the alleys, obviously. But one thing that I like to highlight in this image is this, I think it's walnut, but I'm not entirely sure, European walnut. The one thing I highlight here is to think about the successionary nature of a system like this, especially with larger trees. You know, you can think about an alley cropping system. I'm going to have an alley cropping system with walnut and lavender. And that's a neat system, right? But in 20 years, the lavender is not going to grow in that system because it's probably not going to have enough light in this system. So it might be that this system is starting as an alley cropping system and then transitioning more to just a nut production system or a timber production system. And a lot of times alley cropping systems are designed that way, that they're not necessarily an alley cropping system for the entire life of that particular system. It's just a transitional or a successionary development of using alley cropping in that system, just like you think about ecological succession as that woody crop matures. This is similar to that system I showed you with the corn and the Gliricidia. Here you've got a tree crop that's been pruned very heavily, right? So if you're thinking about a system where you are pruning that tree crop, maybe to get benefits like nitrogen fixation in a soil that really could use some organic matter and some biological nitrogen inputs. Also, you can see maybe in a system like this where you've got some terrain, helps to prevent erosion and soil loss from a system like that. But then also you don't have to worry about that above ground management of that interaction because you've really removed any of that shading. But of course, you're not getting the benefit of reducing heat, but you probably don't need that for a C4 photosynthesis species like corn or sorghum, right? This is mixed grains and mixed woody nut species. So a lot of times we think about that alley as being just one woody species, but it doesn't necessarily have to be, right? You could have multiple woody species within that alley being used rather than just one species, depending on what you'd like to do. And then this image I just like to highlight to think about, especially here in the southeast, we have a very long growing season. There are a lot of crops that can be grown cool season, so those light dynamics change quite a bit in the winter versus the summer, right? You have very low ambient light in the winter, but also a deciduous species is not going to remove much of that light in the winter, so it's less of a concern. Especially as you think about cool season vegetables, you start to think about the morphology and the phenology of those leaves of the tree species. All right, so in summary, potential benefits of alley cropping systems well established in research. There's not a lot of research, though, from climates like ours. Most research in alley cropping is in the tropics. There's not a lot into subtropics, warm temperate to temperate regions. So we're trying to address that with some research that we're doing in Tennessee and some here in Kentucky, which we're going to talk about next. But before we do that, maybe we pause for 5 minutes for any questions on that first part. Any questions? And Jody will bring you the mic. Yeah, we're at halftime, so it's perfect time. Yeah.
I just had a question about nitrogen cycling with perennial tree roots, thinking in terms of like tilling in a cover crop of clover, not necessarily being the equivalent of trees association and nitrogen largely, I think, for its own benefit, not to disperse it through the system as far as, I guess it just relates to the, how much nitrogen for a crop would you expect from tree roots in the
So from a legume, your question is how much nitrogen you might expect to a crop from a legume tree species or a nitrogen-fixing tree species? That is a great question. It's one question we are trying to answer in our research in the second part. So if you think about something like a legume tree species, that legume tree species do fix a lot of nitrogen. Nitrogen fixation is mostly tied to biomass production. So if you think about a nitrogen-fixing tree species, it produces a lot of leaf biomass in one season, right? So there's a lot of nitrogen in that leaf biomass. It might be as much as a few hundred pounds, right? But at the end of the season, what happens to that nitrogen is the question, right? So some of that nitrogen as you go through the season, like, you go into a period of drought, that legume is going to senesce some leaves. So they're going to have nitrogen in them. You're going to get some nitrogen from that. At the end of the year, in the fall, a lot of that nitrogen in those leaves, some of it's going to translocate back into the woody parts of that tree, but some is lost as those leaves fall, right? They have nitrogen in them. So you might get, the research has shown, just from leaf fall, right? You might get something like, you're probably like 40 to 80 pounds of nitrogen, something like that. But then it depends on how many trees you have per unit area and all of that. You get a little bit from the roots, like, as roots die, root turnover type thing, but not a lot. So it's not a huge amount if the tree is just shedding its leaves. But now go back to a system where you're pruning them to the ground, it can be a lot more, right? Because you're not waiting for the tree to drop those leaves so the tree doesn't have time to translocate any nitrogen back to its woody tissues. So you're cutting all of that biomass just like a cover crop and incorporating it so it can be quite a bit more nitrogen.
Yeah, we got one right here too. Yeah, I was just going to ask, you said that you've had increased pest problems in some of these alley cropping systems?
It's a potential. We have not. We've just started, but you can potentially have increased pests. It just depends on how that environment changes, what crops you have, what your pests are in that particular system. It's just something to be aware of is what I was saying. Yeah. But one thing you could think about is, if you think about foliar pathogens on vegetables, a lot of times it's driven by how long that leaf stays wet. So if by your alley cropping system, you increase the amount of time that leaf stays wet during the day, you could potentially increase infection time, right? If the sun doesn't dry it first thing in the morning, that's generally not good. But just depends on the system. Yeah.
I'm just curious where the system is located that had the potatoes and the hazelnuts. Where's that at?
You would have to send me an email,
Okay.
and I would have to look that up.
I'm just curious.
I forget where I pulled that image.
Thanks.
I think it's in the U.S., but I'm not sure. Yeah.
I really love seeing the different types of systems you had in the photos there. What do you suggest for resources, whether it's books or organizations that have some like tried and true, crops that work together?
Good question about resources. I do have a slide at the end, and we can maybe revisit that when I get there. There's probably some that aren't on there that would be really good resources. You will find some resources just from like NRCS. with alley cropping, a lot of that's, again, it's more geared towards not vegetables, either field crops or with grazing, but there are resources out there that are still going to be relevant for you. But I do have some links at in the last slide, I believe.
You might have alluded to this earlier when you were answering a question, but I just wanted to clarify. Are you aware of any research that has shown that legumes like black locust can slough their nodules in the same way that clovers can if there's defoliation events? Or
there's probably not much research on that. It happens, though. I'm fairly confident it happens, right? As they're losing leaves, they're senescing above ground material. They do the same thing with fine roots below ground, and maybe in different parts of the soil. Just depending on what happens. And then also, if you have tillage, right, you're going to remove roots, and those roots are going to decompose and everything too. So, yeah, good question.
It's a little late now, but that I happen to know because I use that same slide. That's in the UK, that potato.
Oh, is it? Okay.
Hazelnut. Yeah, there's
Yeah.
a fabulous European agroforestry project.
Yeah, I do have that link at the end, Agroforestry Center, I believe it's called in the UK.
Yeah.
Thank you.
This is a good bunch of questions.
Hi, you mentioned that fruit trees as woody might have some extra challenges, and I was just wondering if you could briefly touch on like what those challenges are.
Yeah, so as you think about a fruit tree, especially with a vegetable crop, right, you've got two high management crops. And so I think fruit trees work better with a low management alley crop, right? Because if you think about, it depends on the fruit tree, but if you're thinking about something that you need to get in there and manage multiple times per year, maybe with equipment, doing that with a vegetable crop growing might be difficult. If you're using pesticides, even as organic pesticides, they have to be compatible with both crops. So that's my main thing there. I think if you want to get in there with a fruit crop, it's nice that you're using something like grains. Maybe they're harvested before those fruits ever get harvested, before you have a lot of that management in that system. But maybe it works with certain crop types, but I think those are the compatibility is the big issue there. And they're both high value crops, right? So you're going, there's always competition for resources, human resources for high value crops. So I think maybe that's a little bit more complex to manage. But I think they work. I think probably the best systems are you either have a high input fruit crop with a low input vegetable crop, or the opposite. Some native fruits don't require nearly as much input as other fruits do. I think pawpaw and persimmon probably would work pretty well. And there are some systems like that. Jody's going to talk about elderberry a little bit. Same thing. These are crops that don't have a lot of pests typically, so it's a little easier maybe to manage. Yeah.
Any others before he continues? I'm gonna bring this to you.
Don't be scared.
We're all figuring this out as we go, I promise you.
So you said walnuts.
Yeah.
Everything, including my ag extension, tells me to stay away from my walnuts when I'm planting anything. So you're ally cropping with walnuts. I'm confused.
Yeah, so some people do use black walnut. I mentioned allelopathic interference is an issue. Not all crops are susceptible to black walnut allelopathy, so it just depends on the crops you're growing with it, but that's something that you would consider. A lot more is with, what we call English walnut or the other species, which does not have as much allelopathic content, or pecan, things like that. But yeah, it'd be something to think about. A lot of vegetable crops especially would be susceptible to black walnut allelopathy.
And to chime in on the black walnut thing too, we do a lot more natural areas management that I do more than I do ag stuff, just to put all that out on the table. Walnut is thought of as an all or nothing thing, and it's just simply not true. There's lots of small fruit crops that work perfectly well, and grains and herbaceous things that work with walnut.
Yeah, and you can find those lists. There's lots of resources that will talk about what crops are susceptible to black walnut allelopathy.
Yeah, what about hawthorn, willow, witch hazel, so medicinal trees?
What was the one you said before, willow?
Can you use these medicinal trees as together with the with the vegetable or another herbs?
Yes,
crops?
yes. So the question is about other types of trees that might be for other resources. So I think those woody cut systems have a lot of potential. So They're used a lot in Europe, like with willow. You think about willows that are harvested for making baskets and other things like that, right? So it's very similar to that hazelnut system, right? Because that's just going to get to be a large shrub, and then you cut it and you harvest that material and it regrows. And especially if you have a site that's maybe a little wetter, and it helps to dry that site a little bit for vegetable production. So those are definitely potential. There could be a lot of other things. You mentioned witch hazel. I don't know as much about witch hazel. But you also see, pussy willow, red twig dogwood, yellow twig dogwood. A lot of those are used for ornamental cuts. And so a lot of growers like those things too, especially if you have some kind of market for ornamental crops. Yeah.
Okay, we'll give David a chance to continue on, and you'll have some more opportunities for questions right at the end.
All right, so I'm going to talk a little bit about the study that we've implemented at UT. So this is at our organic unit, so it's under certified organic land. And our objective here is to evaluate black locust alley cropping for potential use for organic vegetable production. We're looking at a lot of different things in this study. We're looking at crop yield, quality, and disease incidence. We're looking at carbon, nitrogen, and phosphorus cycling. We're looking at how those trees affect the microclimate. We're looking at how those trees affect crop physiology, things like photosynthesis and stress and things like that. And then we're also looking at how those trees change the relationship of below ground organisms like mycorrhizal fungi to each of those species in that system. So I didn't mention this earlier, so when we first established this study, 2 years into the study, we looked at the grasses that were associated with the roots that were associated with the alley cropping systems versus the non-tree systems, and we saw higher mycorrhizal colonization where we were growing them in the alley cropping system versus the open field no tree system. And there are good reasons to think that might happen, right? Mycorrhizal fungi, this is a fungal network that has to have that relationship with plants to maintain that fungal network. And so those trees help to support that network, and then those new herbaceous plants come in as annuals and they can tap right into that existing network. And so it's less work to establish that relationship. So we're looking at some of those dynamics in these systems. So we have three what we call main plots. And so these, we have black locust, which is a nodulating legume. This is black locust. Many of y'all might be familiar with black locust. It's a native tree species to the eastern US. It is a nodulating legume, so classically what you think about legumes, they form root nodules, right? Those root nodules are infected by rhizobia bacteria. Those bacteria fix nitrogen from the atmosphere and then provide it to the plant, and in return the plant gives it some carbon, some sugars to help support it, right? So that's the typical relationship we know with legumes, and they provide a lot of nitrogen, and so that's the nodulating legume. We also have what's called a non-nodulating legume. So a lot of woody legumes don't form these nodules. Some herbaceous legumes don't either, but a lot of woody legumes don't do this. And it's generally assumed that if a legume doesn't nodulate, it doesn't fix nitrogen. That's probably not true. That's probably something we believe that's just not true, because there's some recent research that suggests that's not entirely true. But we do know that it's a much lower rate of nitrogen fixation if there is nitrogen fixation happening. So we have this non-nodulating species, honey locust. We're using thornless honey locust. So it's also a native species. It's a legume and has a very similar growth habit to black locust. Grows just slightly slower, but the leaves are similar size, similar shade, similar height, those types of things. And then we have a control, which is no trees in this case. And so why do we use black locust? I mentioned a few of these. High nitrogen fixation, rapid growth, late leaf out in the spring and fairly early leaf drop in the fall. It also senesces leaves anytime it comes under drought. The shade is more dappled, so it doesn't create this complete shade that you might get, if you think about something like, I don't know, a good example, sugar maple, right? Very complete shade under a sugar maple if you have one in your front yard, right? With a large canopy. Versus black locust, there's a lot of light that comes through that canopy just because of the size of the leaves, the way those leaves are arranged on the canopy structure, those types of things. It's also a marketable wood species. I don't know I don't know how widely it's used in various regions still, but historically, right, black locust was largely used where treated fence posts are used today. It's very naturally rot resistant, so it's used in a lot of applications where you need rot resistance, and it's great, of course, for an organic standpoint because you can use it as a rot resistant lumber that doesn't have treatment. And it's native to the eastern US. There's really not a lot of cold tolerant woody legumes. So as you go into the tropics, there are lots of legume trees like Gliricidia that fix nitrogen, high rates of nitrogen that are used in alley cropping systems, agroforestry systems, coffee and chocolate systems as living fences. But there are just very, very few that will survive in climates and the cold temperatures that we get, like here in Kentucky or Tennessee. So black locust is really one of the very few. It's the only one that's native, really, that would produce this high rate of nitrogen fixation. Albizia also works pretty well for nitrogen fixation, but that's a more invasive species. It's not native to the US. Most people call it mimosa. You see it along the roadsides. So that's a high nitrogen fixer, too. And then honey locust, as we mentioned, it's a non-nodulating control. So what this allows us to do is we can separate somewhat the microclimate effects that we observe from the trees from the nitrogen fixation effects that we observe. So we're getting microclimate from both species, not in our no tree control. We're getting nitrogen fixation, at least high rates of nitrogen fixation, only from black locust, not really from honey locust, and then of course not at all from the no trees. And so conceptually, this is our design. We have our tree species, and you can think of the rows running away from us, just like we have these beds of vegetables here. And so just theoretically, what's happening is we have litter fall containing biologically fixed nitrogen that adds to nitrogen in that system. We have nutrient uptake from the biological nitrogen fixation of the black locust, an extensive perennial root system accessing greater root volume and established relationships with endophytic fungi like mycorrhizal fungi, helps to take up more nutrients, and then some of those nutrients are lost in leaf fall and cycle to that vegetable crop. And then we have modified microclimate conditions that are more favorable for vegetable crop growth and quality and for comfort of agricultural workers. So you can also think maybe there's some social benefit to an alley cropping system. A benefit to the humans that are working in that system too, right? If there's less heat stress on the crop, we would think maybe there's less heat stress on the humans too in a system like this. So that's our theoretical model. Also, theoretically, you've got different microclimate environments. So you can see maybe we're growing more shade-tolerant, less heat-tolerant crops in those alleys that are in those rows that are closer to the trees. Maybe we're growing other crops in the center of that alley, get more light, more heat, etc. We also have what are called subplots experimentally. So with each of our large plots, and we have 4 of each of these plots. So we have 4 black locust plots, which each consist of 3 rows of trees that are 75 feet long. But then within each of those, we have 2 what we call subplots that allow us to look at something else. So we have a low nitrogen rate and then a standard nitrogen rate, what we're calling a standard nitrogen rate. And what this allows us to do is look at how much these trees might increase nitrogen use efficiency in these systems, right? We might expect, we might hypothesize that black locust system, maybe we can get similar yields with our low nitrogen rate as we might get in the open field with a high nitrogen rate. So this is what this is going to allow us to answer. So I mentioned our design. Just briefly, we have 3 rows of each species in each plot, and of course we've got a lot of replication in the study, but our trees are 26 feet apart. This was taken last year after some pruning. You can see there, and we're going to chop those up and incorporate them. But the reason we have 26 feet between plots, that's fairly close, but again, think about the successional development of the system. We have 3 rows because our thought is that probably with maturity we'll harvest the center row, and then as the trees are larger, we'll go on with a wider alley. So you can think about it that way, successional development. If you want to maintain the alley cropping system, maybe start them narrower, and then you can remove 1 row and go to a wider alley with maturity, especially if you have a species like this that you could harvest 1 of those rows as that system develops. So I was raising the canopy here. They had already wilted. It was a pretty hot day. So this was a cover crop that was mowed. And then we had just put the limbs that we cut to raise the canopy. And then we go through with a flail mower and then incorporate them and do the tillage before the summer vegetables are planted. So that's what was happening there. This was tillage. This is a honey locust plot I see there. One thing you might notice as you think about management challenges, I mentioned it earlier, what do you do in the row? Something to think about. Sometimes you can get pretty close. A tree species like this, back to the fruit question, right? I don't really care if the tractor hits a few of these trees. And the tractor did hit a few of them. They'll get, knocked down, twisted up. They usually bounce right back and they're fine, right? Apples aren't going to do that. So it's nice to have one crop that is a little more stress tolerant than another crop. And then here, another weed issue here, but here you see squash is growing at this time, here between some black locusts. So just again, maybe allows you to think a little bit about these systems. All right, so I'm going to turn it over to Jody because I've really run out of time here. Few resources. There is the Association for Temperate Agroforestry, fairly simple link there if you want to write that down. There's the Center for Agroforestry at the University of Missouri. They have a lot of links on their site. So that's a good resource for our climate. The National Agroforestry Center, that's from the USDA Forestry Service, I believe. And then we mentioned the Organic Research Center with RE spelling in the UK with the hazelnut resource. Yeah. All right, so I'm going to turn it over to Jody. He's going to talk about elderberry for a little bit, and then we'll take any more questions.
Yeah, I'll be super brief. Oh yeah, let's go ahead and give David a hand. Thank you for that. And David, feel free to jump in. The session's almost over, and if you're coming to the panel, the alley cropping panel, we got 3 farmers implementing alley cropping, and I'm just going to be asking them questions, and you'll have the opportunity to ask questions. So if you want to know a little bit more about elderberries, you can get some more of that at this very next session in the very next room. But we're doing something very similar, except we're not using trees, we're using elderberries. And elderberries is a native shrub, small fruit crop, multi-million-dollar market for that in the US already. That's another reason we're doing it. We decided not to go with trees because the performance period of our grant is short. And we simply wouldn't get what we needed to out of trees within the time that we had. So what's something that's extremely tolerant, it's very popular, it's growing like crazy, nearly anybody can grow it, and folks are already making money on it now. We're looking at elderberries, and we're looking at annual row crops. So would you mind going back to just any one of your slides that showed like a plot? Yeah. So basically, yeah, it looks very similar to this. We have 2 rows of elderberries where they're about 30 feet apart, and then we have, and then the alleys themselves are about 65 feet long. And we have, they're basically divided in half. One half of that has elderberries, the other doesn't, but everything gets the same row crops. So we're looking at bush beans, we're looking at bell peppers, and we're looking at acorn squash. We needed different families of things also for disease management. And really the question we're asking is, how well do these things grow together? Are there environmental benefits from using this heavy flowering native fruiting shrub? Does it provide soil health benefits? Does it provide pollinator usage benefits? Do we see any effect on marketable yield and plant health? We just installed this in 2023, and we've got some cooperators in Kentucky. One in particular is in the back of the room right now. Oaks, raise your hand. Right back there. He's been doing his for about 1.5 years now, and you can talk to him about some of his details about what he's doing with that, and you'll hear about him in the next session. But it's basically what David had mentioned. We're just simply using a different cropping combination. So we have 2 rows of elderberries, and then we have 3 rows of these crops, right? So our stuff, we're not having to worry about shade. So it's simply these other benefits that we're examining. And one of the ways that we would deal with shade if we had to, maintaining a long-term woody crop, is you saw in some of the slides that you can use different spacing. For example, if you're looking at long-term nut crops with long-term forage or grain production, you'd probably be looking at something at like 40 to 60 foot alley widths, right? But in our cases, we're looking at something very small. And another thing we want to examine is just, is it going to be effective as a space-saving option? And it's really that simple. We just got into it, and we have a new farm on the west side of Franklin County that KSU bought, and that's where that is. But at the same time this year, we're going to be developing workshops at these elderberry sites in Kentucky and advertising that as like extension programs. So be on the lookout for that. With that, our time is about up. I do encourage you to come to the panel, which is focused on these farmers and what they're doing with their alley cropping. And with that, once again, thank you very much, David, for all this, and we'll see you in the next one. Thank you.